Okay, how's everybody doing today? We're going to be working on the Unit 8 review, starting with multiple choice on page 54. I'm going to go through all the multiple choice here, and then we will do the proofs on some separate videos. So let's just get started. Number one, in the diagram of triangle ABC and triangle DEF below, AB is congruent to DE. So let's mark those up. AB, DE. Angle A is congruent to angle D, and angle B is congruent to angle E. Which method can be used to prove triangle ABC is congruent to triangle DEF? Actually, when you have these, B and E, they're congruent to each other, but not A and D. So I gotta make sure I mark that right. So we've got angle, side, angle. Number two, nice and simple. All right, down to number two. As shown in the diagram below, AC bisects BAD. So if it bisects, we have two congruent angles. Okay, and angle B is congruent to angle D. So I've got two angles. Okay, so when you have two angles, it's either angle, angle, side, or angle, side, angle. Now, is there anything I can do with AB and AD? There's nothing that says anything. So it looks like angle, side, angle is out. AC is congruent to AC. So we can use angle, angle, side. Which method can be used to prove triangle ABC is congruent to ADC? Angle, angle, side. Number four. All right, on to the back. This one looks a little more complicated. We'll see. In the accompanying diagram, CA is perpendicular to AB, and they give you the right angle. ED is perpendicular to DF, and they give you that right angle. ED is parallel to AB, so we know these are parallel. So when we're looking at parallel, we're going to be looking at some type of alternate interior or corresponding angles. Always think of that off the top of your head. CE is congruent to BF. So this piece right here, BF and CE, but we know that EB is the same. So these two sides will eventually be the same. Okay, that's an addition postulate. AB is congruent to ED. So AB is congruent to ED. And measure of angle CAB equals the measure of angle FDE, and they're both 90, but we got that from the perpendicular lines. Okay. Now, which statement would not be used to prove triangle ABC is congruent to DEF? So if we look, we've got right angles, we've got alternate interior angles, we've got this side, and then because we have the two angles, we know the third angles will also be the same. So the only thing we're missing is DF and AC. So that means we can't use side, side, side. Okay, we can use hypotenuse, leg. Here's the hypotenuse and the leg. As we said, we have to use the addition postulate. Angle, angle, side, again, we have that. And side, angle, side. We're good with that. All right? So that's what I like to do. I always like to double check the answers that are not correct. In the accompanying diagram of triangle BAT and FLU, angle B is congruent to angle F, and BA is congruent to FL. You just hear my phone in the background of my house. Sorry about that. I'm just going to let that ring. I'm going to keep going. Which statement is needed to prove triangle BAT is congruent to triangle FLU? Hold on a minute. Okay, that was more annoying than I thought, so I made sure it got off. And now they're leaving a message. Okay, whatever. Which statement is needed to prove triangle BAT is congruent to triangle FLU. If we have A and L here and here, we have angle, side, angle. So that looks to be good. But let's check these others. AT and LU, there is no side, side angle. Angle A and U are not even corresponding pieces. And parallel has nothing to do with each other unless you're looking at something like in 3 and it's all in one picture. All right? So the answer is going to be number 1. All right, moving on. Question 5. In the diagram below of triangle AGE and triangle OLD, angle GAE is congruent to angle LOD. Here we go. They marked that for you. And AE is congruent to OD. They marked that for you. To prove that triangle AGE and triangle OLD are congruent by side, angle, side, what other information is needed? So we have side, we have angle. We're going to need that side and that side. So AG and OL, and that's number 2. Right. On to 6. Triangle ABE and triangle CBD are shown in the diagram below with DB congruent to BE. So that's just this piece here. Which statement is needed to prove triangle ABE is congruent to triangle CBD using only side, angle, side? Now this could get a little confusing. So what I actually did was I drew the 2 triangles separately. Okay, there's B, there's A, there's E, and we had point D right about there. Now the other triangle looks like this. See if I can slide that over so you can look at it. This was D, B, C, and E was right there. Okay, now we knew B is the same on both of these. So we're all set there. And then we know that DB, this piece right here, is congruent to BE. So this piece and this piece. Now we need side, angle, side, they're saying. Okay, so we have one side here, the angle, and the other side. Now we know in each piece of the sides are congruent, but we need the other pieces to be congruent, AD and EC. So that's what's needed here for side, angle, side. The others might be helpful for certain things, but when specifically side, angle, side, AD and CE. Okay? Going on to number 7. In parallelogram ABCD shown below, diagonals AC and BD intersect at E. Which statement must also be true? Okay, so let's see. They intersect, so parallelogram, we know these bisect each other. Okay, what must also be true? AC is congruent to DB, not in a parallelogram, not the diagonals. In a rectangle or a square, yes. Angle ABD, this piece right here, is congruent to angle CBD, and we know that they don't bisect, so that's not good either. Now, triangle AED, so this triangle here, and triangle CEB are congruent. Well, we have the 2 sides, and we also know, because these are vertical angles, those are congruent. So that's the true one. That's side, angle, side makes 3 correct. Okay? Moving on, number 8. Kelly is completing a proof based on the figure below. She was given that angle A is congruent to angle EDF, and has already proven AB is congruent to DE. So AB and DE. So we've got a side and an angle. Which pair of corresponding parts in triangle congruency method would not prove triangle ABC is congruent to triangle DEF? So let's see, if we had AC and DF, we would have side, angle, side. That's correct. if you have BC and EF, that's side-side angle. We don't have that, so that's no good. That's your answer right there, okay? They want the one that does not work. Number 2 is the one that does not work, all right? Number 9, 2 right triangles must be congruent if an acute angle in each triangle is congruent, okay? That doesn't make them congruent, that makes them similar, okay? All of your angles would be similar. You'd have a right angle in each triangle, and then an acute angle in each triangle is congruent, which means the second acute angle in each triangle would also be congruent, but has nothing to do with the sides. That just makes it similar. The lengths of the hypotenuse are equal. You can have 2 right triangles with the same hypotenuse but different legs, so that doesn't make them congruent. The corresponding legs are congruent. If you have the corresponding legs congruent, that gives you side angle side, so that's going to be your answer. Okay, nothing to do with areas. We haven't done anything with areas, so you don't have to worry about that. All right, so I'm going to move on to the last page, number 10. In the diagram below are 4 pairs of triangles are shown. Congruent corresponding parts are labeled in each pair. Using only the information given in the diagrams, which pair of triangles cannot be proven congruent? Okay, here we go. We have side, side angle, side, side angle. We have no side, side angle. So that should be the answer. Let's just double check. We've got angle, angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg because of the right triangle. Okay, so the answer there is going to be 1 for number 10. When we look at number 11, the diagonal AC is drawn in parallelogram ABCD. Which method cannot be used to prove that triangle ABC is congruent to triangle CDA? Now, normally I would draw this out immediately, but if you just take a look at your answers, one of the answers doesn't even fit. There is no side-side angle, okay? So that cannot be used to prove. We have no side-side angle. So you can take that one right out of there. Now, 12. Which statement could be used to prove triangle ABC and triangle A prime, B prime, C prime are congruent? Which could be used? So I'm going to draw this. I'm just going to draw 2 triangles, A, B, C, and then A prime, B prime, C prime. Now if I have AB and A prime, B prime, BC and B prime, C prime, and then angle A, I've got side, side angle. That's no good, so we're going to throw that out. All right, now we have AB, A prime, B prime, A and A prime, C and C prime. So that gives us angle, angle, side. That's a good one. We can use that one. I'm just going to double check the others. Angle, angle, angle is not congruent, so that's no good. And then I have angle A and A prime, AC, A prime, C prime, BC, B prime, C prime. Again, side, side angle, no good. Number 2. Okay, I hope this multiple choice was helpful. And now I have to go check on my phone message. I'll be back with page 59, the 3 proofs there on the next video. Hope everybody's doing well. Take care, thanks, and good luck.